All right, welcome. Today, we're going to go on a little adventure. We're going to see how a simple agent with basically no instructions at all can learn to make some incredibly smart decisions completely on its own. Yep, we're diving into the story of Q Learning. So let's kick things off with the big question, the one that really drives this whole field, right? How in the world does a machine learn from its own mistakes just by trying stuff out, without someone programming every single possible move? This question, it's right at the heart of a really powerful part of AI. And the answer? Well, it all comes down to this really cool idea called reinforcement learning. And honestly, the concept is beautiful. You've got an agent, that could be a robot, a piece of software, whatever, and it learns by getting feedback from its world. It's honestly a lot like training your dog with treats, except, instead of treats, we've got data. And instead of a dog, we've got an algorithm that's just trying its best to reach a goal.
Okay, so to make this all feel a bit more real, let's meet our hero for today. Everyone, meet Qbot. Qbot is our simple little agent, and its whole mission in life is to find rewards in the world we're about to create for it. So take a look. This grid, this is Qbot's entire universe. That's it, just 6 squares. And Qbot can move between them. Now you'll see there's one special square, the one marked G for goal. If Qbot makes it there, it gets a huge reward. We're talking 100 points. Everywhere else, a big ol' 0. So its whole quest is to figure out the best way to get to that prize. All right, first things first, we need to get on the same page with some lingo. So where is Qbot at any given moment? We call that its state. It's that simple. For our little Qbot, each of those 6 squares on the grid is a different state it can be in.
Okay, so if a state is where you are, what about what you can do? Well, from any state, Qbot has choices. It can try to move up, down, left, or right. And these possible moves, we call those actions. See? Pretty straightforward. A state is where you are, and action is what you can do.
And here's where it gets really important. Actions. They have consequences. Every time Qbot takes an action, the environment gives it some feedback, and we call that feedback a reward. In this world, the reward is plus 100 for that final winning move into the goal state, and yeah, a big fat 0 for every other move it makes. This feedback, this reward system, is literally the only thing Qbot has to guide it.
Okay, so how does Qbot actually remember what works and what doesn't? It's not just going to wander around forever and hope to get lucky, right? Nope. It actually builds a kind of secret map. Let's take a look at how it does that.
This map, this is the famous Q table. You can think of it as Qbot's brain, or maybe its cheat sheet. It's just a table that lists every possible state and every possible action from that state. But here's the thing. At the very beginning of its journey, this table is completely blank. I mean, look at it, all zeros. Qbot is completely clueless. It has absolutely no idea which moves are good and which are bad.
And this right here, this quote from the source material, it just perfectly captures Qbot's ultimate goal. It's not just trying to find the next reward. It's trying to learn a whole sequence of actions that will get it the biggest total prize over its entire journey. It's all about the long game.
All right, now for the really cool part, the magic. How does Qbot turn all this random wandering, all this experience, into that useful map? Well, there's a secret formula it uses to update its Q table with every single step it takes.
The whole learning process is just a simple repeating loop taken right out of the Q Learning algorithm. It goes like this. Qbot in a state. It picks an action. It gets a reward. It lands in a new state. And then, and this is the absolute key, it updates its map based on what just happened. Then it just does it all over again, and again, and again.
And here it is, the secret formula. Now I know, it might look a little scary with all the letters and symbols, but the idea behind it is pure genius. Just stick with me. The new value for a move is the immediate reward you get, plus a little piece of the best possible future reward you could get from the next state. See that little gamma symbol? That's just a number between 0 and 1 that tells us how much Qbot cares about future rewards. A high gamma means it's patient. It's playing the long game. This formula is how it connects an action now with a great outcome later.
Okay, let's see this thing in action. Imagine Qbot is right here, in state S1. It looks at its map, the Q table, and the map says the value of going right is 0. Total blank slate. But, it's got to try something, so it decides to take the step. It moves right. And boom, the update happens. So Qbot moved right, it landed in state S2, and its immediate reward was 0. Bummer.
But from S2, it takes a peek ahead and sees that the best move from there could eventually lead to that big 100-point reward. So using the formula with a discount factor of, let's say, 0.9, it crunches the numbers. The immediate reward, 0, plus the discounted future reward, which is 0.9 times 100, gives it 90. And just like that, its map is updated. It has learned that moving right from S1 is actually a really, really good idea. Okay, now I want you to imagine Qbot doing this not just once, but thousands, maybe even millions of times. Just exploring, taking steps, and updating that map with that one simple formula over and over and over. After all of that trial and error, something truly amazing happens to its once blank map.
Just look at this. The map isn't blank anymore. It is filled with numbers, with values to represent the hard-won wisdom Qbot has gained. Now, from any square on the board, Qbot can just look at its map, find the action with the highest number, and it knows, with total certainty, that's the best possible move to get the biggest reward in the long run. It's figured it out. It's found the optimal path from anywhere.
So what Qbot has actually built here through this whole process is something we call a policy. And it's more than just a map, it's a complete guide for how to behave. A policy tells the agent the absolute best action to take in any situation it might find itself in. And that's the holy grail of reinforcement learning.
Now, I know what you might be thinking. A robot in a tiny grid? It seems like a simple little game, but I really want to be clear about this. This exact story, this process of learning from rewards to build a policy, it's the engine behind some of the most incredible technology that exists in the world today.
And this isn't just theory. As the source material points out, reinforcement learning is used to teach actual physical robots how to navigate really complex spaces. It's being used to optimize massive factory operations and supply chains, saving tons of money and time. And, maybe most famously, it's the technique that was used to create AI that can learn to play incredibly complex games, like backgammon or Go, at a level that no human champion can even touch.
So let's end with this thought. We've just walked through the simple, almost elegant building blocks of a system that learns completely from its own experience. And if a simple bot, like our little Qbot, can learn a perfect strategy for its world, just imagine, what truly complex real-world problems could we solve next just by letting an AI learn the optimal policy? The quest, really, is just beginning.